I assume that you will join our previous session in the morning. It talked about PureScript. It's a young and useful language. Want to know more about it? Our speaker Justin Wu will take us into this journey about type-safe, type-level, type-driven solutions with PureScript. Please show your welcome to Justin Wu. Thank you.
Okay, thanks. Thanks for coming. Yeah, and so I'm going to talk about PureScript today and a lot of things that type systems can do for us. And just for trivia's sake, like I'm not actually the Wu that's like talking about PureScript because my last name is like Yu in Chinese, but the Korean name is Wu. So, Wu and Yu, two different people. So yeah, Derek wrote me this like really nice intro, but I can't really read it. But in the end, the only thing that actually matters is that I made this meme about last year. So it's like typically what happens with the type system whenever you like sabotage yourself, either willingly or unwillingly, right? So if you make a function that takes 3 strings and gives you back a string, then like what does it do? So that's kind of like the kind of stuff I'm going to talk about. So this isn't a normal introduction, right? Like this morning, CT talked about PureScript and tried to like introduce people to it. He also talked about some advanced concepts, but at least there was like some kind of introduction. So what this talk is actually going to be about is I'm going to talk like generally about what PureScript is, not actually about like what the language is or whatnot. And I'm going to talk about some kind of interesting things about PureScript that kind of overlap with Haskell, a little bit overlap with some other languages, but a lot of things that are just not in other languages because, well, not a lot of languages are based on research from the last 20 years. And I'm going to show you how like the computer can do a lot of repetitive and error-prone things. So like a lot of things where you might write a lot of boilerplate, like generate hash code, definitions, getters and setters and whatnot. Like that, a lot of that kind of stuff can be done away with, especially like JSON deserialization. And then hopefully like me showing this kind of stuff will get you more excited about like learning about PureScript. If not to use it, then to just like see what kind of things are out there, just to like influence what you do in the future with other things. So what is PureScript, right? It's like a language that's similar to Haskell, but it's not the same, right? There's a lot of like implementation differences, a lot of things that come with trying to run on JavaScript and having a lot of interrupt with it. And it implements a lot of like newer ideas than what Haskell has. A lot of core Haskell work is done in the 2000s. PureScript, really a lot of the implementation work has been done since 2015. So just like the last 3 years, implementing a lot of stuff that's happened in like the last 10 years, you can just get a lot more stuff, and you kind of have the benefit of hindsight about like the stuff that Haskell missed. And unlike most annotation-based languages, types are first class. So if you've used TypeScript, you kind of have these annotations where you kind of you have a lot of unsafe data that you're just coercing unsafely whenever you have type annotations. And so you just hope that whatever you're working with does follow whatever type annotations you give it, right? And then whenever you work with type annotations, what you do is that you might say it's a union of 4 different things, and you might type guard on it. And you hope that the information that you've written down is correct. Whereas in PureScript, you actually use the type system things as first class. So if you have a data type, then you have constructors of that data type, and you can actually pattern match on those constructors and know that the value is actually going to be the correct thing in runtime. The other thing that PureScript does is that it gives you a lot of tools to encode more information in your code base. So this is really like represented in this quote, like make invalid states impossible, right? So a lot of languages like kind of take this to first level, and then some other ones take this to like a second level. So PureScript like lets you encode more information with richer types, and then use a lot of different things to actually validate those. And then one of the other key differences from other languages is that there's no actual like thought leader group for PureScript. I mean, some people might call me a thought leader, but I don't try to actually prescribe what anyone should do. I just say, hey, here are some things you might consider reading about, some things you might do, but sky's the limit. Like, you can do almost anything you want. You can do as little as you want, but you actually do get this, you get a rich array of tools to scale forward and scale back your code's information. So when I say make invalid states impossible, like what I'm saying is that this isn't a binary property, right? It isn't like you suddenly can make all the impossible states impossible, because you just can't do that. There's a lot of things where, like, say you might have dependent type systems where you say, like, this number must be 2, but then that doesn't enforce, well, that's only like the most primitive kind of check. It doesn't enforce a lot of things that are more complex systems. So what make invalid states impossible really is that it's a spectrum, right? You can choose like how far you go in encoding how much information there is. So the simplest example is that we have like a type alias here. So we can say type URL1 is going to be equal to string. So anywhere you have this URL1, you can read the type signature and you kind of get some information that it's supposed to be a URL. But then structurally, it's actually the equivalent to a string. So you can define a function that takes this URL1, and you can just pass it any string you want. So it's exactly like this meme where you've like defined a function as string to string, and then, well, you can pass any string you want into it. So can you be surprised if it doesn't work? The more like nicer way to do it is to use a new type. So this is in runtime, it's the same as having a normal string. And the idea is that you actually have this constructor where you can choose to actually either export the constructor, so your consumers can actually use this constructor directly and say URL2 and then some string value, or you can make URL2 function and you export it out, right? So when you export out this function, you might do a lot of validations, and then you might return the result as an either. You might say like left side, you have some kind of error, or right side, you kind of have some kind of a successful URL creation. But this is only as good as your make URL2 function, right? So if your make URL2 function only tests if it contains HTTPS, then like an FTP URL won't pass that test and it'll be invalid, even though it's supposed to be valid, depending on the context. So the more advanced thing you can do is that you can actually work with refinements. So you can, there's plenty of ways you can encode refinements, but like one way you could do it is to have these opaque data types, like data has @ or an is Gmail. And then you can make a row type of validations on this new type. And you can say that URL3 can be constructed with a string where I have these validations applied to it already, so that when you create this value, statically in a concrete code path, you know that has @ validation and a is Gmail validation has been run. And this is called a refinement type, and it's like something that you typically don't see, but it can be quite powerful to work with. But yeah, I mean, what is this like pound type thing, right? So pound type is a row type of type. So the pound actually takes a parameter for any kind of kind. So a kind being a type of type. So when one concrete example would be when you think about records. Like in a typical language, a record is kind of like a built-in, like a hard-coded struct thing. But in PureScript, it's actually a data type where it's parameterized, and you can actually work with it as a parameter of record. So if a record has statically defined fields where you have static label names, so you know at that label you will always have whatever the type you associate with is. It's heterogeneous, right? It's not a hash map. There's going to be, you can say that a specific label has an int or a specific label has a string. And the other thing I forgot to put in here was that these fields aren't ordered, right? The ordering of fields in a record is something that just doesn't exist. So we might say that like my type my record, apple, banana, cherry. Like we could very well define it as banana, apple, cherry. And then in here, like one of the most common cases might be, okay, what if I don't have a value for this? In the JS hash map, I might say that I might just put undefined or never like actually try to assign a value. And in those cases, you should actually use the data type to say, okay, it can be a maybe string, it can be nothing, where nothing has been defined for this, or it can be just some value. So the field syntax is sugar for this record data type. So data record is actually just a normal PureScript type where it takes this pound type, row type parameter. So once you pass in that row type parameter, then you actually have a concrete type you can work with, and there's like valid values for that type. So if you have type myRealRecord, it's going to be equal to record with this row type parameter. So apple int, banana boolean, cherry maybe string. Like this row type, you can use it in other contexts also. But then in this case, if we give it to record, then we get the equivalent record definition as this myRecord definition. So other than that, let's think about some cardinality, right? So if we have a sum type that's int or boolean, we know that there are n+2 states associated with it, right? So there's n number of integers, or it can be well, in this case, with the constructor isn't. So there's one constructor, so that's like a cardinality vector of 1, with the argument of int, right? So there's n number of integers values it could be. So one side of the sum type is n. And then the is boolean, there's only 2 states for a boolean, right? There's the true and false. So this is the other branch that it could be. So it's a constant factor 1 times 2 on the other branch, so you have this n+2 states. So if you put this together into a product type, then you have the multiplication with other arguments here, right? So if you have a record, which is basically somewhat equivalent to a product type, we could say that is submitted is going to be interboolean, and then it can have a date argument that's a JS date. And if we just pretend that a JS date can have n number of values, n number of possible states, then we can say that the total number of states that this myData1 should have, it will be the quantity n+2 times n. So, you know, it could be any array of dates, and it could be any state of is submitted. Kind of like when you roll like a D6 and a D12 for dice. And then let's also look at this other case, right? We can say myData2, like submitted JS date. It can be n number of states or not submitted, 1. And this is something I will use in this example. I lost some code. But anyway, this is similar to the interboolean as above. So the thing I talked about briefly earlier is something actually a homogeneous map, or is it actually a record? So if you have a given key, is the field going to be undefined or interboolean, right? So if we have the interboolean type, then, well, if our map actually does contain value for that key, it'll be the interboolean, but it could also be undefined, right? So like if you have a lookup function, it's going to always give you this maybe interboolean. And this map is homogeneous, right? It only has one type it can contain. But then if you have like this record mythings2 that actually represents what this is going to hold, then this actually specifies like what field has what type, right? So apples, you will always know that that field is int, and is chair room, you will always know that it's a boolean. And whenever you construct this, it will always have those fields. It's like it's guaranteed, whereas if you work with a JS object, then you're going to have, it could be a record where for a given string, it can be undefined, or it could be like some other kind of types. It doesn't necessarily have to be homogeneous. So if you ever want a map of some type key or value, but you already know what keys you have, then it's almost always a record, right? But this is actually the boring part, right? Types aren't really just for checking your work. Like, since we have computers nowadays that can do like, well, millions of calculations, we should at least be able to take advantage of research done since the 80s to generate a lot of routines that we routinely write boilerplate for, right? So one like clear example is that decoding JSON should be free. So if you, this doesn't mean that like JSON should always deserialize to your domain model, but if you have a transport model you can define, then you should get the JSON decoding for that for free. So if you have static information available already, by defining these types, like say this my JSON type, then decoding this should be like quite straightforward, right? Like if you did this by hand, you would write some kind of operation that has that can fall out early, where you say, okay, read from this blob, read it as an object, make sure it's an object, then read field apple and read it into string, make sure it's string, and then continue on with the rest. And then once you have the whole complete result, then putting it together. But like, we don't have to actually write this boilerplate, right? If we can define a generic function that actually uses information, we can do this. And so I wrote a library called simple JSON, which can actually take that information from before. So one example would be, okay, we have this main. Let's do log show decode to my JSON. And so I'm going to pass in some JSON, apple, red, banana, 2. And in this case, it's going to give me the result in either, right? So because it's successful, it gives me the right case, and it says, okay, I've parsed out correctly the record, apple red, banana 2, and then cherry that we had over there is going to be should be just false here. That's a typo. And then in the case of the banana red, banana wrong, apple red, this banana was supposed to read into an int, so it's going to come out as left side, where we have a non-empty list of errors that have been banana, like it didn't match the type for int, where it was actually a string. So how does this actually work, right? This works with type-driven programs, right? So if we can work with the concrete type that's available in our context, we can always derive some kind of routines from that, right? So if I had the type class read foreign for some given type A, and I have a read implementation function, then I can read the JSON, or read from some foreign JS object into my type. So this says that like, so for read string, I would say read foreign string where, and then my read impl would just say, okay, like check that the foreign value is actually a string, and then if it is, then return it. And I have the same thing for array, but in the case of array, it's parameterized, right? It says, okay, I know how to read an array, but like what are the actual inner elements? So then this asserts that, okay, A must be in the set of types that have an instance for read foreign. So I can, if it's a read foreign array int in the context, like if I want to read out to an array int, then I can read out from the int that each thing is going to be int. And the same thing goes for maybe, where I can say, okay, where I can define methods to say, okay, is this foreign value I'm getting out, is this undefined? If it is undefined, or if it's null, then I can give it to nothing, and I can just construct nothing and then push it back. But then if there is something there, then I need to actually read it into some kind of thing. So over here also I say that A must be in the set of types that have read foreign, and I can read foreign into that. In the case of the record, then I actually take the row type information. Remember earlier that the fields with the curly brace is equivalent to record fields. This will be this fields is unordered information, but we can turn it into a list so that we can actually iterate it, and then we can do this read foreign fields and say that we should read this from this list into some kind of thing where we can get out the actual fields. So what is row to list? It's this class. It's this compiler type class that can take that row type information and turn it to an iterable list. So that means that like if I define a concrete function to RL proxy, at the value level, it's just going to be RL proxy in the end, after I've done the conversion. So if I pass into this function a proxy of my record, so just the type level evidence carrier for my row type, then it can give me this RL that I can use in other contexts. So what does it mean? I mean, it means that there's actually two different stages that go on here, right? Like most people think about their code being that whenever you write like some kind of Babel script, you write the thing and then it reads the AST And then from the AST, you generate the actual target code. But here, there's an entire separate stage that says, okay, what are the types of my program? What are the constraints that are here? Can I actually run this through and solve a lot of things? Can I actually like normalize things? Generate an actual core representation that actually contains like everything once everything has been like solved out, like this static type information. And then once I have that, then I do another round where I actually produce an AST and then produce the actual output. So this is what's called type level programming. And so this lets us do things like this RL my JSON, where I can say that like given my proxy of my JSON, I can actually get back this type level information about the list that it is. And then that lets us write instances for this read foreign fields class that I have here. And I can actually just match at a type level for nil and then match for cons. So this is actually analogous to writing normal term level code, where you might say, okay, I have a list. I want to match that list element, and I want to match the end of the list. This is just done at the type level. So there's a lot of examples of different programs. So one example might be doing some type level routing between server endpoints and front-end requests. So I did this for work where I have an Express application, and then my front end is going to be some like Redux thing, right? And I use node fetch to, I use the browser window fetch to do a request. So I can actually use this information to say, okay, does my route actually exist in this row type of routes that I've defined for my endpoint, for my server? And then what are the request types that it expects? And then what are the response types it expects? I can actually get this information to it. I can also implement this cycle.js thing, but type safe. So if you're at all familiar with cycle.js, there's this concept of drivers and sources, and it syncs to drivers. So if you put out ABC from your main function, then your ABC hooks up to drivers that then return things that are hooked into ABC. So it's a cycle of dependencies. So we can do this. We can do the refinement types that I talked about. So the way at the beginning, we had this URL3 with the validations of a row type. So we have this opaque data type, has @sign, and is Gmail. So we can actually write code that says that whenever we want to define this, we can actually statically generate all the code needed to verify all these, validate all these properties instead of writing the boilerplate ourselves by hand. There's some other things like decoding INI files. So if you just have like key value pairs inside of sections, you can also do that. You can diff differently typed rows. You can exhaustively patch polymorphic variant records, and like a lot of stuff. Polymorphic variants here mean if you have the row type information for creating a record, if you just flip that around and you make the code product the sum type, then you can say that for each label there is a value that exists that has that type. So a lot of things that are pretty exciting can be done with this type level programming and the static type information that you actually wrote by hand. And so with that, you don't actually have to write any boilerplate anymore because you have all the information there, such that you can write a generic implementation that you can just check once that the implementation is correct. And then for all of your types, your implementation is derived from the correct code. So this also leads to some other thing where we can do type synthesis with a lot of other type information. So like, let's say I define this function, getIm, like ignoring the type information, the type signature up there, I have a query here that I'm going to run, right? And it's going to be a statically defined string. So this S proxy just carries around some type level string information. So if in my type level string, I say select name count from my table where name is parameter name and count is parameter count, then I can actually go through the type level information, extract out the labels for my record type, and then synthesize the record type such that the record type can say, okay, I can take any A that is of an allowed parameter type and any B that is of any allowed parameter type. and it maps to these the dollar name and dollar count properties. So if you've ever written just like a simple query with like node SQLite, node Postgres, or something like that, then instead of having to write a lot of tests where you just test that you've supplied a parameter and that you can actually run some kind of dummy query that doesn't blow up on runtime, that you can actually have this property checked statically so that you can actually test more interesting properties about the query that you've written, about like the information that comes out of the results of your queries. So I've talked about this in Milan 2 weeks ago, and like you can look it up online if you're interested about this. But yeah, this is like really just tip of the iceberg. Like a lot of the things I talked about here, even though it seems dense, it's only like 10% of like what the PureScript community has achieved, right? So like the only answer I can really give you is to learn PureScript. And there's a lot of various ways you can use PureScript, right? You can use it where you write some small modules that you import into existing projects. So this is something I've done a lot of work where I have some logical code that I write in PureScript that has to do with like state transitions and fetching some data and whatnot. And I just import those as common JS modules into my project. So that works. You can hoist PureScript or PureScript like module in JS. Like you can just like call that module that you've written, or you can like define some kind of a React component in PureScript and then import that into JS, right? And you can use it there. Or you can also bring JS and use it into PureScript, right? Either through some factory functions, or you can actually define in the FFI like some kind of React components that you want to work with, and then you can just bring those in and use them in PureScript with some annotations for what the imported type is. And you can also just make some small applications to existing libraries, right? So my first PureScript project was actually a chatbot that checks a certain website to get me some torrents. So that kind of stuff, like I used to do manually, but then I could just use like the Node Telegram API Node library in order to actually drive some messages and have it check things on a timer. And so like that's also like a nice way to get into doing some PureScript. Of course, doing PureScript requires a lot of upfront investment, right? So like a lot of the things I showed you here, they're like at least the implementation is kind of on the advanced scale. But at least the front half about like how to avoid invalid states in your program, and then working with like sum types and working with records. That's like a lot of stuff that's very foreign that you'll have to read into. So that's at least like you have to do a lot of reading about that kind of stuff. You look into also the PureScript effect library and a lot of the other core libraries to see like how a lot of this stuff is supposed to interact, especially with like JavaScript runtime. And learning about the FFI, like how to do like foreign import, whatever, is like a really like important thing. And it has actually some immediate payoff where you can like instantly get started with PureScript, where you can go from hello world to calling some kind of library. But this does also like involve like plenty of time to get used to. And finally, like it actually does require a lot of community engagement to use PureScript, right? So there's a local user group here, PureScript Taiwan, and that CT is involved with. And there's a discourse where you can ask questions in like a typical like forum format. There's like a Slack channel where you can talk about for PureScript and PureScript beginners on this FE chat. So on Slack, you can ask questions, or like you can also ask me questions directly, and I can try to point you to things that you should read or try to answer you directly. But as a language that has a pretty small community, you do actually have to like engage a lot with the community to get things done. Whereas like it's not so much the case if you use React that you have to get in the community so much. You can already use existing solutions. But yeah, I mean, my talk was like pretty short, but that's about the gist of my talk. So thanks for having me.
Thank you, Justin. And if you guys have some question about PureScript, please follow Justin's Twitter. There's a lot of interesting on it. Thank you. I will see you later in